All right, so for this particular experiment, we're going to be comparing the transfer of heat energy in various materials, and you're going to be plotting data. So again, I don't want you to watch a video of me literally boiling water or watching it cool down, okay? So essentially, I'll tell you what I did, and I'm going to show you some of the materials I used here. All right, so this is the procedure that was followed. So what I did was boil water in a saucepan on my electric stove. It's a flat top stove. And I brought 3/4 of a cup of water to boil in a small saucepan. And this 3/4 of a cup of water went into each of a metal measuring cup. Okay, so it's a 1 cup metal measuring cup. It went into a styrofoam coffee cup right when it was boiling. So 3/4 of a cup went into each of these items. It went into a glass Pyrex cup. So again, this is a 1 cup measure, though there's a little more room at the top of this one than in the 1 cup metal cup. Okay. And then it also went into my favorite mug, which is a Yeti. So, you know, the Yeti cups are meant to keep things hot for a really long time, cold for a really long time. So, right upon boiling. So, I assessed boiling, obviously by the rolling boil, but I took the temperature of boiling. I quantified that using my handy dandy thermometer here. All right, so I took the temperature and assessed that it was boiling. So 3/4 of a cup went into each one of those right at the time it was boiling. And then a thermometer went into each of those cups. And every 30 seconds, every 30-second intervals, I measured the temperature as these were cooling down and plotted it in an Excel sheet. Okay, so I did all the hard work. All right, so what you guys are going to do is graph all the data in the Excel sheet. All right, and then you're going to interpret the data. So again, I didn't want you to have to watch me boil water and then cool it down. So I just wanted to show you what I have used. So I'm going to give you a peek at the spreadsheet here. Boiling, cool down. Oh, wrong one. There you go, container material. So as you can see, I plotted the styrofoam temp, the metal temp, the glass temp, and the Yeti mug temp. And these are all in Celsius. And then what I want you to do is graph the time versus temperature. So time will be on the x-axis and then temperature will be on the y-axis. And then each condition will be on a separate line using the line chart. Okay, and then you're going to answer the questions in the form of a lab report, but use those questions, critical thinking for questions, or I'm lying to you. There are no critical thinking questions, but you're going to essentially assess that data for you know what cup cooled down the fastest and why, what cup maintained its temperature the best and why, and this is because of the container material. But I want to just remind you that the cups are all different heights, so there's a little bit less height on the metal cup, more height, so empty airspace on the glass cup, a wider width on the styrofoam cup, and then again, the Yeti is probably the largest cup. So 3/4 of a cup didn't even come to halfway on the Yeti cup. All right, just for your note taking. And also my house is a little cooler than room temperature. So when I measured the temperature of my home, it was 69 degrees on the thermostat. So it wasn't even 72 degrees. So my house is a little cool. I did have a ceiling fan going and that kind of thing. So take all of that into consideration when you're explaining what was going on. All right, but if you have any questions, please post them to the general questions forum so I can answer them for everybody. And I can't wait to see what you come up with.